Hi, this is Mark Schuyler. We're going to look at complex numbers. And even though this is a pretty big topic, you don't need to know that much about complex numbers on the SAT or the ACT. So let's jump into what you do need to know. So on the next slide here, I have a little note, a little reminder to you and to me that this video does assume you understand the basics of imaginary numbers. If you need a quick refresher, please watch my imaginary numbers video. It's short, it's fun, and it's a prerequisite for really understanding complex numbers. Well, what are complex numbers? They're actually just a mixture of real numbers and imaginary numbers. And they're supposed to be written in the form A plus BI. And let me just explain that. The 5 is in the A spot right here. The 3 is in the B spot. And here comes our buddy I, the imaginary unit. And obviously we have a plus sign, but we could have a minus sign. So what do you need to know about this mixture of real and imaginary numbers? They're just going to make sure that you know how to add them, that you know how to subtract them, that you know how to multiply them, and you know how to divide them. So if you can do the 4 basic arithmetic operations, the 4 basic operations of sum, difference, product, and quotient, you're going to be fine. And really, the sum operations, this one right here, super simple. You would just treat I like any other variable, like the variable x or the variable y. So we follow the golden rules of algebra. We're going to add together integers with integers, numbers with numbers. 5, sum means adding, so 5 plus -8 is going to be -3. You want to write that first. That's the A. And then we want to come up with the BI. So we're going to sum the 3i and the 4i. That sums to 7i, where I is acting like just any other variable, x or y. You just combine like terms. Pretty simple, huh? And product is also super simple. You have to multiply these out, but you follow the FOIL method, which is something that we should be very familiar with. Make sure you go in order. Definitely want to put a warning here. Let me change to red. This warning is the absolute truth. The truth is, this is where people make more mistakes than anywhere else on the Math SAT. It's just a mistake breeding ground when people have to FOIL to find the product of 2 mixed numbers. Excuse me, 2 complex numbers, which is a mixture of real and imaginary. So just go slow. That's my advice. If you know that this is the place where it's a mistake breeding ground, where that's where everybody is blundering, making all their mistakes, don't be a statistic. Go slow. Okay, there's your warning in red. So let me change back to blue. We want to go and multiply the 5 times the -8. This is part of the FOIL method, first, outer, inner, last. We get -40. And then we want to do the outers ones in each binomial. So 5 times 4i is plus 20i. Then we want to do the inner ones. That's going to be minus 24i. And then we want to do the last ones. Okay, let's check it out. That's going to be a positive 12i squared. Don't forget that 3 times 4 is 12, but I times I is I squared. That's important. Now, we have to combine like terms. You can see that we have a 20i and a minus 24i. So if we're combining terms, we can say minus 40, -40. This would be minus 4i. And over here, we get a little substitution opportunity. We have to see that the I squared is really negative 1. So 12 times negative 1 would be minus 12. Negative 12. And we can now combine this guy and this guy together, and that would be minus 52 minus 4i. That's your answer right there. So finding the product, you have to go slow, but there we have it. What I want to show you on the next slide is really the only situation you have to be careful about with complex numbers. If you're dividing one complex number by another, it's not going to be just like 4 divided by 2. Okay, some people make this mistake. They think it's going to be, well, 4 divided by 2 is 2, and then I just have to divide the positive 2i by the negative 4i, and maybe they might think that's, I don't know, negative 1/2 I, right? Because 2/4 is 1/2. So no, that's not right. Let me get rid of that. I don't even want to look at that on the page. So what we have to do is remember the complex conjugate. Remember it from school? See, you're not allowed to have this I in the denominator of a fraction. There are certain things that are not allowed down there. Remember, 0 is not allowed down in the denominator. It's an illegal operation. It's undefined. And you're not allowed to have square roots. You're supposed to rationalize the denominator. If you have root 2 in the denominator, root 3. Well, if you see I down there, you also have to get to work. But you're going to multiply by the complex conjugate. So you look at the denominator and you multiply by 2 plus 4i over 2 plus 4i. You change the sign. If the denominator had been a positive sign down there, if it had been positive, then your complex conjugate would be 2 minus 4i over 2 minus 4i. Just change the sign in between the two terms and multiply by that. And guess what? It's the mistake breeding ground again. It's not hard to do, but doing it without making a goofy, simple error that you regret, that is the trick. You don't want to make that kind of silly mistake. So we're going to FOIL in the numerator. We're going to FOIL in the denominator. Let's be careful about it. We don't want to be a statistic. So that's going to be 8, and then it's going to be plus 16i, and then it's going to be plus 4i, and then it's going to be plus 8i squared. I'm going to take care of this I squared when I come back and simplify. Let's just leave it like that and tackle the denominator. Now the denominator, once again, we FOIL, but we're going to have 4, and then we're going to have 8i. But notice what happens here. When you do the inner term, you're going to have minus 8i. You see, that's why we're multiplying really by the complex conjugate, is that these guys are going to cancel each other out. You lose your middle terms. And then the last step of FOIL is the negative 4i times the positive 4i. That's negative 16i squared. Remember, we're going to have a substitution opportunity. We can put in negative 1 for both of those I squareds. Yeah, let's do some serious simplification now. I'm going to tackle the numerator first. I have 8 plus 20i minus 8. Oh, well, look at that. 8 times negative 1 is minus 8. So these guys cancel each other in the numerator. And now I'm going to tackle the denominator. We already saw how those guys cancel. So I have 4. But here, when I have negative 1 times negative 16, I get positive 16. So here's our last simplification steps. 20i over 20. And the two 20s divide each other out, and you're left with just I. So this initial mess, well, it looked like a mess, 4 plus 2i over 2 minus 4i, all of this is equivalent to just the imaginary unit, I. So I wanted to show you that with adding and subtracting, let's go back take a look at the previous slide. If this had been what's the difference of those, instead of adding the 5 and the -8, we would subtract the -8 from 5. Remember, if you're subtracting -8, it's really a +8. But these kinds of operations with adding and subtracting, finding the sum and difference, super easy. Just treat complex numbers like any other algebra variables and integers. We saw that product, it's a mistake breeding ground, but only because of silly foiling errors. And just to show you once again, the one really complicated situation is if they give you a fractional looking equation where it has I in the denominator, you have to remember the complex conjugate, and that is going to be whatever the denominator is, change the sign in between, multiply by that over itself, and FOIL super carefully, not only in the numerator but in the denominator. That's it. I hope that helps you raise your scores. Thanks for watching, and I will see you in the next video.